Hi, Simon Smell from GI.healthcare. So in the next of my series of videos talking about irritable bowel syndrome, I'm going to talk about the pathogenesis, which is basically just a fancy medical word for how something comes to be or how it happens, of irritable bowel syndrome. And in the first part of this, I'm going to talk about the gut nerves and the brain and how they interact with each other. And then in subsequent videos, I'm also going to talk about the microbiome and how the microbiome influences and interacts with the gut nerves and the central nervous system. So here we go, the gut nerves and the brain. So where can the gut nerves and brain communication go wrong? And that is kind of the pivotal question in irritable bowel. And it can go wrong in the enteric nervous system, and that's common in the context of inflammation. So if people get gut infection and post-infective irritable bowel, often enteric nervous system is sensitized. It can go wrong in the dorsal horn, so that's basically in the spinal cord or in the parasympathetic nervous system as things are processed on the way to the spinal cord. It can go wrong in the vagus nerve. So the vagus nerve is a very big, important nerve that innervates both the gut and the heart and the lungs. And it can go wrong in the processing of visceral sensation. So when the messages get to the brain, it may influence what goes on inside the brain. So some people send the messages to the wrong part of the brain. And of course, other environmental influence the way in which the brain interprets messages. So disturbance of the hypothalamic pituitary axis, as occurs in chronic stress, and PTSD and numerous other conditions, can influence the way we then interpret messages from our gut. And then lastly, I'm going to talk about the microbiome in a separate video and its influence on the brain-gut axis. So to move on, this is a very modified and simplified diagram of the nerves in the gut. So in the red boxes, we have nerves that go from the bottom all the way to the mouth and send messages that way. The yellow boxes illustrate nerves sending messages from the mouth in the direction of the bottom. The turquoise boxes show you that you've got inhibitory neurons, so neurons that dampen down the response of the gut to stimuli. The stars are obviously neurons that excite your response in the gut. And then the little yellow triangles reflect the fact that there are neurons which communicate between those that go up and down and the inhibitory and excitatory neurons. Now, there are more nerves in your gut than in your brain. And indeed, you may have heard of dopamine, which is one of the neurotransmitters that helps get us out of bed in the morning. There's a lot of dopamine in the gut. And serotonin, which is the neurotransmitter that makes us feel happy. So SSRIs, which are your standard line antidepressants, are serotonin reuptake inhibitors. And there is more serotonin in the gut than in the brain. So it's really complicated, the enteric nervous system. So it may be disrupted at a number of levels. So it can be disrupted following gastroenteritis or inflammatory bowel disease, where essentially you might, in the response to inflammation, lose some of the inhibitory nerves. And you kind of want that when you've got inflammation, because if you've got a gut infection, you want to get rid of the infection. So you want to get the gut excited, and it gives you diarrhea to get rid of the pathogen. The trouble is, if that persists, that might cause problems like post-infective IBS. And the people also develop hypertrophy, so increasing muscle size, muscle fiber size within the circular fibers of the gut. And these changes may revert to normal, in fact do revert to normal for most of us who get a gut infection, but in those with post-infective IBS, they might persist. Similarly, there's an increasing body of evidence that sensitivity in the gut in IBS might reflect release of histamine around the tips of nerve endings, thus sensitizing the nerve by making it fire at a lower threshold. So that is an important thing in the development of sensitivity. The vagus nerve, really important nerve in the body, controls many of our autonomic functions, including heart rate, breathing, and gut function. And that has a number of influences. It may explain why some people with irritable bowel get abnormal sensations of extra systoles, extra heartbeats, and occasionally that sensation of not being able to get enough air in. And that's often a reflection of sensitivity in perhaps the lungs or the heart. Everybody gets extra systoles, extra heartbeats, but most people don't really notice them. So obviously brain processing is important in irritable bowel syndrome as well. So emotional context and what has gone on and goes on in our everyday lives has a big influence on the way our gut sensation is processed. And that's illustrated if you imagine, if you bang your elbow on a day when things are going well, it doesn't really hurt. If you bang your elbow on a day when everything is going wrong, then it can be really uncomfortable and feels so much worse, and so much more so in the gut where there are so many nerve fibres. Similarly, chronic stress disturbs what's called the hypothalamic pituitary axis, struggling to say that still after 20 years, and that leads to disturbances in the brain in the way we interpret stimuli, particularly pain and threat. So that's also a factor in irritable bowel syndrome. So nerves are really important, but so too is the microbiome. And in my next video, I'm going to talk a little bit about the microbiome and the influence that has on the development of the gut nervous system, but also the central nervous system as well. Thanks for taking the time to listen, and thanks for listening.